Okay, today we shall be doing unit root testing. We shall be doing today unit root testing, and the method is augmented Dickey-Fuller test. So meaning that whether the data is stationary or not, that we shall be checking today using augmented Dickey-Fuller test, and normally we call it ADF test. Normally we call it ADF testing, augmented Dickey-Fuller testing. So that it is augmented Dickey-Fuller testing, and here in the Dickey-Fuller test there may create a problem of autocorrelation. So to tackle autocorrelation problem, Dickey-Fuller have developed a test called augmented Dickey-Fuller test stated below, and that is equation 1, equation 2 and equation 3. So this is the first equation, that is model number 1 or model number 1, and in this model number 1 there is only intercept. So here you can see only intercept, that is model number 1, and model number 2, that is this one. So it has trend and intercept. So here you can see this is trend and this is constant, or we call it constant of the model. And finally our third model is this one, no trend, no intercept. So here you can see there is no trend and no constant. So this is our three model of augmented Dickey-Fuller. Three models. So that is model number 1, model number 1, model number 2, model number 3. And these three models must be satisfied to come to a decision about unit root testing. Meaning that, and here what is our hypothesis? The hypothesis is, what is the null hypothesis? The null hypothesis is variable is not stationary or got unit root. And what is alternative hypothesis? Variable is stationary. So one is null and one is alternative hypothesis. So that is our model, and our these three model 1, model 2 and model 3 must be satisfied to take a decision whether a particular variable has unit root or not. Okay, so there are three things. One is having constant, and the second one having trend and constant, and the third one has no trend or no constant. Okay, so then okay, then suppose it is my model. So here is the y. What is the y? You can see the y. The y is the variable from 1975 until 1995. So this is y. So this is the variable 1975 until 1995. This is y, right? 1975 until 1995. Now we want to check, now we want to check whether the variable, that is y, has unit root or not. That we want to check, that we want to check today. So meaning that whether our variable, that is y, has unit root or not, that we shall be checking today. So now we want to check whether the variable, that is y, has unit root or not. That we shall be checking today. Okay, so the thing is that, so I make it big, our variable. Okay, that is our variable. Okay, so so I choose quick. Then I choose series statistics. Then I choose this one, unit root testing, that you choose. Okay, then here I call it series name. I put y. What is y? Y is the name of the variable. So I put here y. Then I press OK. Then we come here. So actually augmented Dickey-Fuller test has three models. Model number 1 has intercept, model number 2 has trend and intercept, and model number 3 is none. So what is none? There is no constant and no intercept. So all three must satisfy. All three must satisfy to take a decision. All three, that means this. All three must satisfy to take a decision. Okay, so first I choose at label. I choose at label. The data is at label, and then I choose the first one. What is first one? Intercept, meaning that this model has only constant. This model has only constant, and here I choose automatic selection of Schwarzschild information criteria. So we call it lag length selection, and here I choose automatic selection. That means our software will choose the number of lag. So suppose she has chosen 4 lags, and that is called automatic selection by the software. Okay. Then I proceed. Then I choose OK. Right. So here I choose data at label, and here I choose only the intercept, meaning that there is only constant. That is the first model of augmented Dickey-Fuller, right? That is the first model of the ADF model. So then I press on OK. I press on OK. So as a result, I press OK. Then what happens? So after pressing OK, so where is the after pressing OK, so this is the after pressing OK, so this one is the unit root model, meaning that this is I call it, this is the result. And here you can see, and what is our null hypothesis here? Y has a unit root. That is the null hypothesis. And here, you know, the maximum lag was 4. Okay, and this thing is the outcome of the model. So here is two things. One is t statistics, one is p value. Okay, and what about this one? This one is the augmented Dickey-Fuller statistics. That is minus 2.067. And what about this one? Critical values. Critical values at 1% level is minus 3.8. Critical value at 5% level is minus 3.020, and critical value at critical value at 10% level is minus 2.6504. Okay. So here there are 3 critical value. So out of 3, so normally I choose at 5% level. Normally we choose 5% level, meaning that minus 3.020686. So that is the critical value, right? That is the critical value is here. Then what is happening? So here what is the guideline? Okay, you just hold on a minute. So the thing is that I'm taking something from here. So what is the guideline then? Okay, the thing is that just 1 minute, I'm doing something. Okay, then so this is our results. Okay, now the thing is that, so what is the guideline? What is the guideline? The guideline is, I put it here, so you can see from here. So the guideline is, if the test statistics is more than critical value, so here if the absolute test statistics, meaning that there is no negative sign, that is called absolute test statistics, is more than critical value, that is also absolute, right? Then we can reject null hypothesis and accept alternative hypothesis. So that is the guideline. So if the absolute test statistics is more than critical value, that is also absolute, then we can reject the null hypothesis and accept alternative hypothesis. But if we cannot but if the absolute test statistics is less than critical value, we cannot reject null hypothesis. Rather we accept null hypothesis. So that is the guideline all the time. Okay, I'm telling you what is the guideline. If the absolute test statistics is more than critical value, then we can reject null hypothesis and accept alternative hypothesis. But if the test statistics is less than critical value, we cannot reject null hypothesis. Rather, we accept null hypothesis. Okay, then the question is that what is our null hypothesis? What is our null hypothesis? The null is y has unit root, meaning that variable is not stationary. So that is called null. And what is called alternative? Y do not have unit root, meaning the variable is stationary. So that is the alternative hypothesis. Okay. So here what is happening, you can see from here. Okay, so here you can see from here you can see the here the test statistics, how much that is here, augmented Dickey-Fuller test statistics, how much it is 2.0671. so that is a absolute value, meaning that there is no negative sign, and then how much is the critical value? Critical value is how much? At 5% level, 5% level, critical value is here, how much? Is 3.02, right? 3.02, that is critical value at 5% level. So as a result, what is happening? That test statistics is less than critical value, meaning that we cannot reject null hypothesis. Rather, we should accept null hypothesis. So y has unit root, meaning that variable is not stationary. Okay, so y has unit root, meaning that variable y is not stationary. So and also here the probability, what is the probability? the p-value. Sorry, probability means the p-value. P-value. So here is how much p-value? 0.2586, meaning that 25.86%. So that is p-value. P-value. And here, what is the guideline? The guideline is that the guideline I am writing here. The guideline is sorry, what is the guideline? The guideline is if the p-value is less than 5%, we can reject null hypothesis. If the p-value is less than 5%, we can reject null hypothesis and accept alternative hypothesis. If the p-value is less than 5%, we can reject null hypothesis and accept alternative hypothesis. But if the p-value is more than 5%, then if more than 5%, we cannot reject null hypothesis. Rather, we accept null hypothesis. So that is the guideline of our models, right? And here what is the problem? Here the value of p is how much? Here the value of p is 25.86%. 26.86%, meaning that the p-value is more than 5%, meaning that we cannot reject null hypothesis, meaning that we accept null hypothesis. So y has a unit root. Y has unit root, right? Y variable at level, y variable at level got unit root. And here, so actually this is this versus this, that is one way, and also this one is the another way to check whether a particular variable has got unit root or not. So meaning that this is one way, this versus this, that is one way, and the p-value is the another way to check whether a particular variable has unit root or not. Okay, so that means y has a unit root. That is already checked. But make sure. So you go to below. Make sure, and this one is the augmented Dickey-Fuller model, right? And make sure here the coefficient of this variable y lag 1, the coefficient of y lag 1 variable must be negative. It must be negative, and it is already negative. So meaning that this model is viable. The augmented Dickey-Fuller model, that is viable because the coefficient of y lag 1 is negative. Okay. So this is the first model having constant. That is the first model of is constant. Okay, that is first model is constant, and from here y has a unit root. Okay, then actually we have three model. First model having constant. Okay, then what is our second model? The second model having trend and constant. That is our second model, trend and constant. Okay, so I proceed for the second model. I go to view, I click on the view, unit root test, I click on it. Okay, so the second model is trend and intercept, right? Trend and intercept, meaning that trend and constant. So the second model is trend and constant, and here is at level. So I proceed, and then I press I choose the automatic selection as before and press on the OK. Okay, so this is the result. You can see constant and there is a trend, right? What is the null hypothesis? Y has a unit root. Okay, so this is our second model. Okay, here what about this one? This one is the test statistics, and critical value is how much at the 5% level? 3.65. So meaning that what is happening here? Here is what is happening. The test statistics, I just do it here. Test statistics is how much? Here test statistics is 2.52, the absolute value of test statistics, and 5% critical value is around 3.65. So meaning that test stat is less than critical value. So meaning that we can reject null hypothesis and can accept alternative. Sorry, I've done a mistake. Test statistics, yes, test statistics is less than critical value, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis. And the question is that what is our null hypothesis? Our null hypothesis is that y has a unit root. That is our null hypothesis. Y has a unit root, meaning that there is a unit root. And what about the p-value? How much is the p-value here? The p-value is how much? 0.3121, meaning that 31.21%, and meaning that more than 5%. Meaning that so what is the guideline? The guideline is that if the p-value is more than 5%, we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that y has a unit root. But make sure the coefficient of y lag 1 must be negative. It must be negative, otherwise the model is not viable. So okay, so model 1, model 2 done. Now our third model we can check. I go to view as before, then I go to unit root test. Okay, so it is our third model, that is none, meaning that our model has neither trend nor constant, Okay, then I press OK. So this is our results. You can see the null hypothesis y has a unit root and there is none, meaning that this model has neither constant nor trend. Okay, for this model, so how much is the test statistics? Test stat how much? Test stat is this one, right? You can see from here. It is the test stat how much. The absolute value is 1.64. And how much is the critical value? Critical value at 5%, right? How much? The value is this one, 1.95. That is 1.95, right? Critical value. And what is happening here? Test stat is less than critical value, so meaning that we cannot reject null hypothesis, rather we accept null hypothesis. So y has a unit root. Y has a unit root. And here, what is our probability value? P value, you can check from here. P value is how much? P value is 9.26%, meaning that more than 5%. So we cannot reject null hypothesis, rather we accept null hypothesis. So, but make sure this y, the coefficient of y must be negative, and it is already negative. So this model is viable. Okay, so what is our decision after checking 3 models? So our decisions of ADF model decision at level that y has unit root, or variable y is not stationary, stationary at level. So that is our decision about y variable after checking 3 models of augmented Dickey-Fuller test.